Hey everyone, this is a short video on chapter 12b. Now, a bit of background to this chapter is in that intro to the unit circle video or the things we did in class. And what we discovered is that in the unit circle, the x coordinate or this distance here is equivalent to cos and the vertical y is equivalent to sine. And so in a coordinate it goes cos and then sine. What we're going to do is now find some answers to when they give you the angle. So having a look, have we got it written out? Well, we've got it written out here. If you've got cos theta and you're filling in this part here, so if something asks you, what is cos of 30 degrees? You're finding the coordinate x that matches up with that degree. So having a look at question 1, for each of the following angles, find the values of sine t and cos t. So you're finding the value of, at 0 degrees, what's sine, what's cos. At 3 pi on 2, what's the sine and what's the cos. Now, unfortunately, they've mixed around the question. You might want to do cos and then sine, okay, because you're going to read it like that off your unit circle, okay, because cos is x and sine is y. So you basically got two answers for these, and I just wrote to do the left-hand side. You can do a couple more if you want to get good practice at it, but okay, evaluate the following using your calculator. So you're simply typing that in. So it's something you could do an alternative for 1 as well. If you typed in sine 3 pi on 2, you could also find the answer to it. See if you can use a unit circle for 1 though, but you won't be able to for 2. It's telling you that it's radians. It's got small numbers, which is a sign that it's radians as well. Usually we talk it in pi, but these ones are decimals. But yeah, the fact that they are smaller, because radians are larger, you don't fit many into a circle, so you often get smaller numbers. You don't usually see something like 60 radians, because obviously that's going to go around and around the circle many times. Okay, speaking of going around and around the circle, question 3 is looking at that. So what we have is radians that are, I guess, larger than what our unit circle has. So if we have a look, so it's example 6 it's equivalent to, so having a look at 9 pi on 2, forget our unit circle up here, here's 1 pi on 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've ended up in the same place as 1 pi on 2. So that's one way of working out these answers, is just going around until you hit it. The other way of thinking about it is the fraction 9 pi on 2. We have to think of splitting it up so that you are left with lots of 2 pi's. So think of 2 pi's as a whole rotation. It gets you back to the same answer. So I know that 9 is the same as 8 plus 1. And the reason I've chosen 8 is because 8 divided by 2 is 4 pi. 4 pi is like 2 full rounds of the circle. So that just cancels out. So what they're showing here is that 9 pi on 2 is the same as, and the step they've missed that I would probably write is that it's the same as 8 pi on 2 plus another pi on 2. And that cancels down to 4 pi. And 4 pi will just disappear. It's going to get the same answer. You go round the circle, round and round again, and land in the same spot. And then all we have to do is find the answer of sine pi on 2. So another example would be if I was at pi on 6 and someone asked me to find sine of 13 pi on 6, I know that 13, I could think about, 12 divided by 6 gives me 2 pi. So I can cancel that 12 out of there. So 12 would be 2 pi, so that would be like all around, back to here again, that's a 2 pi rotation. And so it would be the same answer as pi on 6. So 13 pi on 6 for sine equals a half, and pi on 6 for sine equals a half. So have a go at question 3 there, at seeing if you can take out lots of 2 pi. So remember, a full rotation is 2 pi's, okay, and that's the only thing that you can cancel down. Okay, that's chapter 12b done. Thanks for listening.